Developers deploy autonomous agents to handle complex tasks, but once initiated, these processes often run in the dark. You trigger the agent, wait, and hope. Operating in isolated shells, these agents make independent decisions, modifying local files, calling external APIs, and spawning entire hierarchies of subagents entirely out of view. Without real-time visibility, an agent can get trapped in an infinite logic loop, repeatedly calling the same tool or reading the same file. It fails silently, consuming thousands of expensive model tokens per minute. Diagnosing these failures requires structured telemetry, but operators are usually stuck watching a raw terminal feed, trying to decipher a chaotic stream of unstructured text output. ClawMetry replaces that blind terminal watching. It is an open-source, local-first observability engine built specifically to capture and map the execution paths of autonomous agents. Getting this visibility requires zero configuration. By executing a single command, pip install ClawMetry, the platform immediately launches a local dashboard on port 8900. There is no need to manually route data or modify environment variables. The system automatically scans the host machine, discovering active agent workspaces, chat databases, and log paths. Debugging agents is no longer about sifting through static text logs after a failure. It requires tracking the precise cognitive and financial steps of the agent as they happen. AI teams are running highly varied tech stacks, extracting structured telemetry from 20 different frameworks without forcing developers to rewrite their application code presents a significant architectural challenge. ClawMetry runs two extraction pipelines simultaneously: passive file parsing and active network interception. On the passive side, a background daemon continuously pulls the host's disk. It reads disparate formats from frameworks like OpenClaw, normalizing them into standard schemas. Custom-built agents operate strictly in memory and do not natively write execution logs to the disk. To capture data from these custom out-of-loop agents, ClawMetry deploys the active network interception pipeline. At the software level, the platform uses monkey patching. It dynamically intercepts standard Python connection libraries like HTTPX and requests at runtime. Every outgoing language model request is intercepted, silently recording model costs, latency, and token consumption without codebase integration. Both branches of the flowchart then converge, dropping their standardized data blocks into a single local DuckDB database. Standardizing all incoming telemetry into a single local store allows the dashboard to run complex queries across completely distinct AI agent frameworks. By combining passive disk reading with active library patching, ClawMetry achieves total visibility across the host environment. Developers get telemetry without modifying their codebase. As agents act more autonomously, their hardware and API demands scale rapidly. Unbounded token consumption is the primary operational risk in multi-agent workflows. The local DuckDB instance acts as an active financial ledger, computing cost metrics on the fly for every single step an agent takes. This maps the cost engine's logic. It evaluates each transaction by multiplying the volume of input tokens by the input pricing and output tokens by output pricing. To ensure exact billing accuracy, the engine then subtracts offsets derived from prompt caching or cache hits. This mathematical engine connects directly to the multi-runtime fleet switcher located in the dashboard UI. When an operator toggles the active framework in the header, the interface immediately applies a runtime filter query parameter to the DuckDB database. This strict query isolation guarantees that traces, costs, and memory tables never bleed across frameworks. Nemo Claw expenses remain distinctly separate from Grok expenses. Tracking raw token counts only gives you system load. By translating those metrics into a live financial ledger, operators maintain exact budget oversight.
Tracking LLM calls covers the agent's internal reasoning, but understanding an agent's behavior requires seeing how it interacts with the outside world. The Active Interceptor module captures all outbound HTTP requests. If the agent queries an internal database or makes an API call to Stripe or GitHub, the system intercepts it. To maintain strict privacy and prevent the capture of sensitive API keys or personal identifiers, the interceptor defaults to logging only the target hostname and the status code. When you review an execution trace, the session routing system queries this external API data directly from DuckDB. These external HTTP hops are then interleaved chronologically alongside the internal tool calls, building a single unified timeline in the UI. By logging every external interaction, operators verify exactly what data the agent requested and which external systems it attempted to modify. Observing a failure provides a debugging path. But running an agent in a production environment requires active governance to stop destructive actions before they execute. ClawMetry implements this control using a local pre-tool use hook installed directly into the agent's configuration files. Consider a high-risk workflow where an agent attempts to drop a database table or force a Git push to a production repository. Before the command reaches the host terminal, the pre-tool use hook intercepts the action and diverts the payload to a local proxy. Running on port 4100, it writes a temporary lock file to disk and returns an HTTP 429 status code. That specific HTTP code officially halts the agent's process in its tracks. The agent is completely frozen, waiting for authorization. The proxy then securely pushes the raw parameters and system context up to the cloud synchronization layer. This triggers a human-in-the-loop validation request on the operator's mobile device, displaying the exact terminal command the agent is trying to run. When the operator taps Approve, the cryptographic validation is routed back down to the local host machine. The local proxy receives the signature, deletes the lock file, and issues a successful response code to the agent, allowing the command to execute safely. If the action is denied, the proxy blocks that specific tool call. The agent session remains active, forcing the model to pivot and find an alternative, non-destructive approach to the task. Placing a local gateway between the agent and the operating system neutralizes rogue actions, enforcing strict human oversight on sensitive system commands. In enterprise software architecture, data silos are a strict liability. Telemetry must be portable to support fleet-scale operations. ClawMetry is designed with a built-in OpenTelemetry export engine, ensuring that operational data is never locked into a single proprietary dashboard. The internal telemetry engine maps all captured agent logs, nested trace trees, and token costs directly into standardized OpenTelemetry blocks using GenAI semantic conventions. By adding a simple command line flag, developers continuously stream execution histories into existing enterprise monitoring stacks. The platform is bidirectional. Its OpenTelemetry receiver can ingest traces from other instrumented applications, creating a fully unified local hub for all observability data. Operating autonomous agents without telemetry leaves infrastructure vulnerable to runaway costs and unauthorized system mutations. ClawMetry's dual-method interception resolves this by normalizing data across 20 different frameworks, providing deep visibility without requiring codebase rewrites. By implementing local proxy hooks, it elevates passive tracking into an active security firewall. And with strict OpenTelemetry compliance, the data integrates cleanly into long-term enterprise deployments. As artificial intelligence scales from chat interfaces into autonomous background fleets, deploying agents requires exact architectural mission control to guarantee financial and operational confidence.